Hello everyone. Today we're going to discuss the last two topics of this chapter. So the first topic that we'll be discussing today is rusting of iron. Now we are quite familiar with this phenomenon. We have seen it in our everyday life. So this would not be that much of difficult to understand. But still we'll be discussing the phenomenon itself. What is rusting? What is rust? How does it occur? What is the main chemical formula behind it? And how can we prevent this rusting? All these things we'll be discussing in this topic. So here's a picture of rusting. You can see clearly that on the right side of the picture there is an iron chain, and on the left side also there is an iron chain, but there is some difference in it. Obviously, first of all, the difference is the color difference. Here it is brownish in color and here it is silver in color. Now in both these you can see some changes definitely occurred. So this change is nothing but this is what we known as rusting. So first of all, let us understand what is rust and what is rusting. So when we leave a piece of iron in the open for some time, it acquires a coating of brownish substance over it. And this substance is called what? It is called rust. So this brownish substance that you can see here in the picture, this is nothing but this is rust. And the change of iron into rust is what we know as rusting. Now, how does this rusting occurs? This is a question that might come up in your mind at the moment. So it is nothing but it is a chemical change or process or reaction. It is a chemical change. Why is it a chemical change? We will see that very soon. But just for the time being, you know it that it is a chemical change. You have already understood in the earlier classes what is a chemical change and what is a physical change. So I will not go to it. So just you know that it is a chemical change, and it can also be considered as a reaction. Reaction of what? Reaction of iron objects with atmosphere, that is obviously oxygen, and the presence of water or air moisture, that is basically the water vapor. So moving on, let us now see what actually happens in rusting. So the process of rusting can be represented by the equation. So this equation will help us to understand what actually happens, what reaction actually occurs in this rusting process, as a result of which the rust occurs or the rust forms. So let us see. So this is the chemical equation. You can see iron represented by Fe, oxygen O2, and in presence of water, that is H2O, it gives us rust. And rust is the name, common name you can say. So but the chemical name of rust is iron oxide, Fe2O3. So remember it. So what actually happens is that when iron reacts with oxygen as well as water, oxygen is available in the atmosphere. So whatever objects you keep outside or inside, wherever it is, the oxygen is definitely there. So you can't escape from it. But if water also gets included in it, then this rust process or the rusting process will occur, and it will lead to the formation of rust, that is iron oxide. So it is a chemical change definitely, because here iron has changed to what? Iron oxide. So iron and iron oxide are not the same chemical compounds. They are different substances, you can see. So this iron has now changed to iron oxide. So a new substance has been formed. So as a result, we can say it is a chemical change. So I hope this much is clear to you. Now moving on, what are the essential factors that are necessary for this rusting process to occur? First is that there should be oxygen. Obviously oxygen is everywhere in the atmosphere. So as I said, we can't escape from it. But whenever in addition to it water is also there, or simply you can say water vapor, that is the moisture in the air, then rusting will occur. So it would not be wrong to say that rusting process is a natural phenomenon, you can say, for iron objects. So wherever there is an iron object, rusting will definitely occur. Yeah, maybe the rusting process may occur very fast or very slow, but it will occur. So iron objects can escape from that. Now next thing is that, as I said, it may occur fast or slow. So when it occurs fast is when the humidity or the moisture in the air is very high. Especially during the rainy season, the humidity is very high. The water vapor content in the air is very high. So during that time, this rusting of iron occurs very fast. You can see it clearly during the rainy season, the iron objects get rusted due to excessive rainfall as well as very high humidity in the atmosphere. But if compared to the winter seasons, the rusting occurs a little bit slow. Now next thing is how to prevent this rusting of iron. This is our main question. So to prevent it, we have to avoid these two factors, that is oxygen and water, or both. So is it really possible? Sometimes we might think that it is not possible because these two things are everywhere available. So it is very difficult to prevent the iron from rusting. But still, there are some alternative methods, you can say. How can we prevent this iron from rusting? So one of the easiest method for prevention of rusting is by applying a coat of paint or grease over the iron objects. Then this grease or this paint, what it will do is that it will avoid these iron objects to come in contact with the air or the moisture. So as a result of which the rusting of iron will not occur. So that's why you can see most of the iron objects are either painted or we apply a grease over it. Grease is mainly used in the automobiles, but generally household stuffs are painted. The iron grills, all those things are painted. So you might see these iron gates, fences, grills, all these things are painted because they remain outside. So there is a huge chance that rusting may occur. So as a result of which we paint. Now moving on to the next. Another method is there that is commercially done nowadays. That process is called galvanization. So what is actually galvanization is that here we apply, or while making the iron, another layer of metal such as chromium or zinc is added to it as a layer, top layer above that iron. So this deposition of layer of zinc on iron or even chromium, so that process is called galvanization. We can see this galvanization mostly in the case of water pipes. If you see carefully, nowadays these water pipes are mostly galvanized. Even other iron objects are also galvanized, not only these iron pipes or the water pipes, but especially in water pipes, because in water pipes always there is a flow of water through it. So after some time, or if we use it continuously, then there is a huge chance of rusting of those pipes, and this may lead to leakage of water. So as a result of which, to prevent this, the iron pipes are generally galvanized. So I hope this is clear to you. You can see one picture here. You can see here the iron pipe, which one is galvanized. You can see this looks like a silver coating over it. It's not silver, neither it is aluminum. It is galvanized iron pipe. And this pipe which is not galvanized, you can see rusting will occur in a due course of time. So that's why it is very necessary that the pipes are galvanized. Otherwise it will lead to rusting, and after some time this rust will cause leakage. Clear? Now moving on to the last topic, that is crystallization. Now what is crystallization? So let us see what is crystallization. Crystallization is a physical change or process. Just now we have read about rusting of iron, that was chemical change, but crystallization is a physical change. And crystallization is nothing but, in short we can say, it is the process through which crystals form or solids form. For example, you can say this common salt. Mostly this crystallization process is used in the formation of salts, any type of a salt, not only common salt, any type of a salt. There are different types of salt, but we have taken the example of common salt because we eat it in our diet. So this crystallization process is very much essential or necessary for the formation of this common salt. So common salt is mainly prepared by the evaporation of the seawater. So whatever residue is left behind, that is the common salt, and then we later on refine it for our eating purpose. So you can see here, this is the common salt crystals. You can see here, these are crystals that are highly magnified, so this looks a little bit larger, but after refining it becomes very small in size, very fine in size. All are uniformly sized, you can see. So how it is obtained, you can see here, this is near the sea areas. There are some salt beds, you can see. There is a boundary, you can see here, and these are salt beds. And when the high tide occurs, the sea water comes in these low-lying areas and get stocked there, you can say. So what happens is that due to this sunlight, this water evaporates, and what is left behind is the salt. Although later on this salt is taken to the factories for the refining process, and then it is used in our day-to-day life. So this occurs due to the process which is known as crystallization process. Clear? Now let us see one example that is given, one crystallization process that is given in a textbook. That is the crystallization of copper sulfate. So copper sulfate is also a kind of a salt. Although it is not eatable, but it is also a kind of a salt. So how to get copper sulfate crystals? First of all, what we do is that we take a cup of water, full cup of water, and pour it in a beaker. And in that beaker again we add some few drops of dilute sulfuric acid. You can see this is the setup. Here in the beaker we have added a cup of water as well as few drops of dilute sulfuric acid to it. Then what we do is we heat it. This is the stand, and then we place it above it, and this is the burner. We lit the burner and then it starts heating. So after some time what would happen? The water will start boiling, as a result of which, as soon as it starts boiling, we will add some copper sulfate powder to it now. This is powder, these are not crystals. We will add some powder to it and continue to stir it with this glass rod slowly by slowly. Then what we do, we will keep on adding until and unless no more powder can be dissolved in the solution. So no more powder can be dissolved. As soon as it heats up, we stir it and get dissolved. As soon as this process will continue unless and until this powder can no more be dissolved. Then what we do is we cool it down without disturbing the solution. After an hour, we will see that we will get this type of residue. So we dry it out, and this is nothing but these are copper sulfate solutions, or we can say not solutions, copper sulfate crystals. So I hope you will have understood this process. You can go through your textbook, read it out again. So this has brought us to the end of this chapter. So I hope you will have understood this chapter. So that's it then. Thank you and have a nice day.